derive the mean and standard deviation of negative binomial distribution, and the PMF of negative binomial distribution is given by x plus r minus 1 combination r minus 1 times p to power x, where p is the probability of failure, then x is the number of failures, times 1 minus p to power r, where 1 minus p is the probability of success, then r is the number of success. And therefore the mean of the negative binomial distribution is given by the summation of x is equals to 0 up to infinity, then x times x plus r minus 1 combination r minus 1 times p to power x times 1 minus p to power r. And therefore, since you want our lower limit of x to start from 1, we are going to substitute 0 into the PMF such that our limit x starts 1. Therefore, when you put 0 into the PMF, you are going to get when you multiply anything by 0, you get 0. And therefore, this one is our E of x is going to be given by x is equals to 1 up to infinity times x into x plus r minus 1 combination r minus 1 times p to power x times 1 minus p to power r. And thereafter there, we are going to reduce, since you want to eliminate this x from this PMF, so what we are going to do, we are going to introduce some binomial, some factorial signs, whereby you are going to say that summation of x is equals to 1 up to infinity x into x plus 1 plus r minus 1 factorial over x factorial into r minus 1 factorial times p to power x into 1 minus p to power r, whereby when you expand this x factorial, we are going to say this one, when you expand this x factorial is the same as x into x minus 1 factorial, whereby this x is going to cancel with this x, and therefore we are going to remain with summation of x is equals to 1 to power and up to infinity x plus r minus 1 factorial over x minus 1 factorial into r minus 1 factorial times p to power x into 1 minus p to power r. And therefore we are going to use some binomial expression terms, whereby when you have something like p to power x is the same as x plus is the same as p to power x plus 1 minus 1, and this one is the same as 1 p to power 1 times p to power to power x minus 1. And also we are going to do the same stuff from r minus p to power r, which is the same as just 1 minus p to power r minus 1 plus 1, which is the same as x minus p to power r plus 1 times 1 minus p to power negative 1. And also when you have something like 1 over r minus 1 factorial is the same as r over r into r minus 1 factorial, is the same thing. So this implies it can be written as r into r over r factorial. And therefore we are going to substitute this one here into our first equation, which is this one here, where is p to power x, we are going to put p to power 1 times p to power x minus 1, and where there is 1 minus p to power r, we are going to put r minus p to power r plus 1 into 1 minus p to power negative 1, and also where is 1 over r minus 1 factorial, we are going to put r over r factorial. And therefore when you substitute in our second equation, in our first equation, we are going to come with summation of x is equals to 1 up to infinity r into x plus r minus 1 factorial over r factorial into x minus 1 factorial times p to power 1 times p to power x minus 1 into 1 minus x to power r plus 1 into 1 minus p to power negative 1. After there, we are going to pull out r, we are going to put r and also p, we are going to put r, p to power 1 and also 1 minus p to power negative 1. And when you pull out, we are going to remain with the summation of x is equals to 1 up to infinity of r into r plus 1 minus 1 factorial over r factorial into x minus 1 factorial times p power x minus 1 into 1 minus p to power r plus 1. So this one we can let it to be our second equation, and therefore after letting it to be our second equation, we are going to introduce some unknowns, whereby we are going to say let w to be equals to x minus 1. And therefore, when w is the same as x minus 1, implying that x is equals to 1. When x is equals to 1, when substituting this one here, you're going to get w is equals to 0. Therefore, since w is equals to x minus 1, this implies that x is equals to w plus 1. After that, also we are going to let s to be equals to r plus 1. And since s is equals to r plus 1, implies our r is going to be s minus 1. And therefore, after, we are going to substitute this one where w is equals to x minus 1 into the second equation. And since we have said here that when x is equals to 1, w is equals to 0. So instead of putting our lower limit in terms of x, we're going to put in terms of w, and we're going to say now rp over 1 minus p summation w is equals to 0 up to infinity into where is x, we are going to put s minus 1, and r, we are going to put w plus 1. So we are going to say r is the same as what? S minus 1 into the x, which is w plus 1, plus r, which is s minus 1, then minus 1 factorial. R is the same as s minus 1, the x minus 1 is the same as w, times p to power x minus 1 is the same as w to power, which is the same as p to power w. And 1 minus p to power r plus 1 is the same as 1 minus p to power s, since r plus 1 is s. And therefore, after there, we are going to say summation w is equals to 0 up to infinity of s minus 1 into w plus 1 into w plus s minus 1 factorial over s minus 1 factorial times w factorial times p to power w into 1 minus p to power s is going to be equals to 1. And therefore, we are going to remain with our e of x is the same as rp over 1 minus p times 1. And therefore, we are going to get our e of x as rp over 1 minus p, and that will be our e of x. Deriving the mean of the negative binomial distribution, we are also going to derive the standard deviation of a negative binomial distribution, where standard deviation is the same as the positive root of variance of a negative binomial distribution, and variance is given by into power x squared minus mean but squared. And therefore, this one is going to be e into x squared minus mean, which is the same as rp over 1 minus p squared. And therefore, we are going to derive, expectation is x squared, which is given by the summation of x is equals to 0 up to infinity, then times x squared into x plus r minus 1 combination r minus 1 times p to power x times 1 minus p to power r. And therefore, since you want our lower limits to start from 1, we are going again to substitute 0 here, and then our lower limits is going to start from 1. After that, when you put here 0, when you multiply anything by 0, you get 0, since 0 squared is the same as 0, and therefore we are going to remain with summation of x is equals to 1 up to infinity of x squared into x plus r minus 1 combination r minus 1 times p to power x into 1 minus p to power r. And therefore, this one we are also going to introduce the binomial expansion knowledge, whereby we are going to say summation x is equals to 1 up to infinity of x squared into x plus 1 minus r factorial over x factorial into r minus 1 factorial times p to power x into 1 minus p to power r. And therefore, one of the x are going to cancel. When you expand x factorial is the same as x into x minus 1 factorial. And therefore, one of the x is going to cancel with this x here. So therefore, we're going to remain with summation of x is equals to 1 up to infinity of x into x plus 1 minus 1 factorial over x minus 1 factorial into r minus 1 factorial times p to power x into 1 minus p into power r, and therefore with this one we can call it to be our equation. We can call it to be, since we had equation 1, we are going to call it to be equation 2. So here we have equation 2. What are we going to do? We are going to say that when you have something p to power x is the same as p to power x plus 1 minus 1, which is the same as p to power 1 times p to power x minus 1, and therefore also 1 minus p to power r, we are also going to use the same idea to expand, where we shall have 1 minus p to power r is the same as 1 minus p to power r plus 1 times 1 minus p to power negative 1, and also r 1 over r minus 1 factorial is the same as r over r into r minus 1 factorial, which is the same as r over r factorial. And therefore we are going to substitute this one into our equation 2, and when you substitute, you are going to come up with the summation of x is equals to 1 up to infinity of x times r into x plus 1 minus we're going to have summation of x is equals to 1 up to infinity of x times r into x plus r minus 1 factorial over r factorial is times 1 minus times x minus 1 factorial, then times p to power 1 times p to power x minus 1 into 1 minus p into r plus 1 times 1 minus p to power negative 1, and therefore after there we're also going to let this one to be our equation 3, and after equation 3 we are going to let w to be x minus 1, and therefore when w is x minus 1 and x is equals to 1, so when x is equals to 1 and you substitute here, we are going to get w is equals to 0, and since we have said that they will let w to be equals to x minus 1, implying our x is going to be w plus 1, and also we are going to let s is equals to r plus 1, and this implies that r is the same as s minus 1, and therefore we substitute in our equation 3, and when we substitute that one in our equation 3, we are going to come up with rp over 1 minus p summation w is equals to 1 up to infinity, then our x is the same as w, x is the same as w plus 1. So where there is x, you are going to put w plus 1, and therefore also r is the same as s minus 1, and x is the same as w plus 1, and r is the same as s minus 1 into factorial over r, which is the same as s minus 1, 1 x minus 1 is the same as w, which is factorial, then times p to power w, since w is the same as x minus 1, and 1 minus p to power s, since s this one represents r plus 1, and after there we are going to expand. This one. So this one is the same as summation of x, of w is equals to 0 up to infinity into w plus 1 into therefore, here this one we are going to expand. This w plus 1 is going to be the same as w, the summation of w is equals to 0 up to infinity, then into s minus 1 into w plus s minus 1 factorial over s minus 1 factorial w factorial times p to power w times 1 minus p to power s, then plus 1, then the summation of w is equals to 1 is equals to 0 up to infinity of s minus 1 in bracket into w plus s minus 1 factorial over s minus 1 factorial times w factorial times p to power w times 1 minus p to power s. All of this one, this one here, where you have the summation of w is equal to 0 up to infinity into s minus 1 into w plus s minus 1 factorial over s minus 1 factorial times w factorial times p to power w into 1 minus p is going to be equals to 1. So we are going to say now this one is going to become can say this one is going to be w into w summation of w is equals to 0 up to infinity into s minus 1 into w plus s minus 1 factorial over s minus 1 factorial into w factorial times p to power w times 1 minus p to power s plus 1. Therefore, what we are going to do, and this when you look at this stuff that we have here, this one actually is the formula that you use to get the mean. So therefore, all of this one is going to be given by expectation of w is the same as sp over 1 minus p. But remember, our s is the same as r plus 1. So therefore, expectation of w is going to be given by p into r plus 1 over 1 minus p. And from our equation 1, we had that our standard deviation is the same as the root of e. And therefore, from the equation 1, we are going to get that it was like e of x squared minus rp over 1 minus p, but everything squared. But since we know what is e of x squared, so therefore standard deviation is going to be the root of each part of e into x squared, which is the same as what? Pr plus p over 1 minus p plus 1 minus, this is r squared p squared over 1 minus p, but everything squared. So therefore, when you expand this one, you're going to come up with therefore this one you're going to have r squared p squared over 1 minus p squared plus rp over 1 minus p squared minus r squared p squared over 1 minus p squared, whereby this one and this one is going to cancel, and therefore our standard deviation we're going to have the root of rp over 1 minus p squared, and that is the end.